Good afternoon, and thank you very much for that introduction and also the invitation and the welcome to DataStorm 2.0. Let me take the next few minutes to kind of explain what skills you need to have to succeed in data science. Actually, 40 minutes is not enough to inculcate the skills in you, but I can give you some pointers on what you should go after. If you want to become a data scientist, or if you want to be part of this very exciting field on data science. I use this image that you have on my introductory slide or the front slide, where you have a big hippo sitting in a boardroom, right? So maybe you have heard about this concept or the effect, what we call the hippo effect. Hippo means highest paid person's opinion, right? So in most of the situations when we want to take a decision, what happens is the highest paid person or the person with the most power or the person with the most influence takes a decision. That's not what we want as data scientists. What we want is people to take decisions based on data, right? So, but we have a big responsibility when it comes to data scientists, because we have to get the data, we have to do the processing, we have to present it in a way so that we can get people, or we can get these decisions made based on data, right? So let's look at how we can do that, or how we can go for that, and what are the skills that we need to become a good data scientist. I don't think I need to motivate you into data science, but let me show some of the skills that you need to have. First of all, you need to have a good educational background, especially the areas of mathematics, statistics, computer science and engineering, and information technology. Those are the educational areas that you need to have. And not only that, some of these we cannot separate them into different boxes, but you also need to have some of the key skills that you need to have with respect to technical skills are programming. You need to know database systems. You need to know about machine learning. Also, you need to have some background in scalable computing when it comes to big data, or you need to have some skills in big data analysis, analytics, and also you need to have some skills in visualization. Not only that, you also need to have some aspects of business in you, kind of being able to use business strategies or come up with business strategies to succeed as a data scientist. You may think that this is all. No, that is not all. We also need soft skills, because things like communication skills, being able to communicate, being able to present, come up with presentation, and also in most cases when we work as a data scientist, you need to work in teams. So you need to have what you call collaboration skills, how to work in teams, how to understand each other, how to succeed. Not only that, lifelong learning, is another very important thing when it comes to data science, because what you do today will not work tomorrow, right? So the challenges are different. The problem is different. The data set is different. Data set keeps changing, right? So you need to be a lifelong learner. That's a soft skill that you need to have. And also perseverance. You can't give up. You can't just, as a software engineer, maybe you can build a system and deploy it and say, okay, I'm done. I can wash my hands off and do something else. But in data science, you have to, I know in software engineering, you need to do maintenance and bug fixing, but in data science, you need to be a person with a skill of perseverance, where you need to keep trying until you get the maximum. Sometimes you might not end up getting the maximum, but you need to strive to get the maximum. And also you need, I said communication skills, but also you need the skill of storytelling. What we mean by storytelling is being able to take some data and some patterns that come out from that data and be able to build it into a story so that you can relate it to the context to which we can apply it. Right, so I think you have got all the skills that you need to become a data scientist. Let me stop there, or should we talk further? Yes, we will talk a little bit further because we need to see why I say these skills are important. Yes, so I'm not the person who is saying this. If you look at what is happening out there, there's this, group that is working on coming up with, because data science is kind of a early, it's a newer field compared to other science streams and fields that we have out there, right? So it's mainly directly related to computing. So ACM, which is one of the biggest professional bodies that we have, they have come up with a working group to look into the curriculums of data science from a computing point of view. And their document is not final yet, but they are they have identified the skills that you should have, or at least they are concentrating on the undergraduate skills. I think the most of the audience that I have here is undergraduate final year students, right? So they have looked into what are the skills that you should have with respect to becoming a data scientist. By looking at what they would be doing in the field, they are not just a collection of academics that are coming up with it. They talk to professionals and look at what happens out there, and they have come up with these areas. Right, so there's a huge document. If you want, you can go and get some more details on it. And actually, I and some of my colleagues at the Department of Computer Science and Engineering spent most of our lockdown period looking into this and coming up with a new stream in data science that we are planning to offer for students at Moratuwa University. So yeah, so let me go a little bit further and give you some motivation as to why we need these skills to become a good data scientist, right? So as I said earlier, I don't need to motivate you as to why data science is important, but let me give a small brief introduction into areas where data science is being heavily used, right? If you look at social networking, advertising, Facebook is making millions out of data science. And if you look at Amazon, the revolutionary way of using collaborative filtering and using it on e-commerce, right? And if you look at how we book taxis and use taxis, I have put Uber and PickMe because PickMe is a local company that is actually using data science. If you look at the banking experience, customer experience now is completely changed because of data science. If you look at the hospitality industry, Airbnb is just an example, right? But and they use a lot of data science in getting giving a better service, making the business more productive. And if you look at music streaming, Spotify is an example that you can come across. And I can go on. 7, 8, 9, 10. I can go on and on and on for. These are some of the major areas that I'm showing you. Right. Let's come a little bit towards Sri Lanka. I said I gave you an example. There are so many other examples. Don't take me wrong for just using PickMe only, right? So let's come back into some of the things that we can do or we have been doing. Unfortunately, although your competition or the challenges on business oriented tasks, the examples that I show here are mostly non-business, because some of the business oriented tasks that I'm involved in, I find it hard to share with because of the NDAs and certain restrictions that we have. Right. So dengue is a disease that we have. Actually, I shared this in DataStorm 1 also. So if you were here in the last round, you might be looking at it with a fresh perspective, right? So dengue, what is the problem? Dengue is spreading rapidly in the country, right? So can we use data science to solve this problem? Right, so I don't think I need to motivate you. Average cases per year is about 30,000. Unfortunately, last year we had a reduction in the number of cases because of the COVID restrictions, right? So, and something that we know is that dengue is a disease that spreads with kind of what we call horizontal propagation, right? People take it from place to place and make it go. I mean, we have a bigger example than that when you look at the COVID scenario. Another example from the ground, fighting the traffic problem, right? So all of you know the problem that we have when it comes to traffic, right? So the Colombo city receives such a big volume of vehicles coming in. And if you look at the cost of congestion, it's about 60 billion rupees that we lose. So can we use data science to solve that? I mean, good example would be Google Maps, where they try to use data science techniques to give us some estimated routes based on the traffic. Can we do better? Can we collect much more data from the ground and come up with solutions that can give us a better understanding of how to solve or how to optimize the resources that we have? Another example from the ground, what about what happens with respect to paddy production? So something that you know is that sometimes we have the rice prices. I mean, rice is the staple diet in Sri Lanka and most of the countries around us, right? So sometimes we have the rice prices going very high, and then sometimes it goes very low. When it goes very high, consumer is having problems, the farmer is okay, or farmer may be okay if he has some rice to sell. On the other side, if the price goes down, consumer will be happy, but the farmer is going to be sad because he has a lot of price to sell, he can't sell it, right? So can't we have a situation, right? So this price goes up and down simply because of the production, not only the production. I mean, we try to control this price by importing rice. So the decision to import rice needs to be taken at the right time. So can we use satellite images to look at these rice fields in Sri Lanka or anywhere, and then try to see what would be the expected yield or expected production in the next 2 months, so that based on that we can take a decision on whether we should I mean, we need to add what is in storage also. Based on that, we should be able to get a better informed decision on whether we should import rice or whether we should stop importing rice, or what we need to do, right? So 3 examples of what we can do. In general, what we try to do with data science is, as I told you at the beginning in the introduction, we try to promote data-driven decision making rather than allowing the CPO to take the decision, so that we can look at a picture, we can look at a visualization and make an informed decision, right? So data science can be done at various levels, or data analytics can be done at various levels. We can do it at a very descriptive level, we can do it at a diagnostic level, we can do it at a predictive level, or we can do it at a prescriptive level. Different areas are there. I'm not going to go into detail, but just to show you the different granularities in which we can look at data analytics and data science. This is once again another slide on trying to understand the fact that data science requires a lot of skills coming from a lot of areas, right? But related areas. We definitely need computer science and IT. We need maths and statistics, and also we need the domain knowledge or the business knowledge, so that if we want to be successful in data science, right? So before we dig deep into a small case example where I would try to show you how you can or why these skills are going to be important for you, let me show you the traditional data science pipeline. Most of you may be familiar with it, but let me take a few minutes to show you what this data science pipeline is. Initially, we have a problem, right? So we are given a problem, right? So we need to study the problem. We need to understand the problem, right? Before that, we can't do anything. Then we need to, I mean, in your challenge case, obviously we'll get the data, right? So we get this, we call it the training data, or we get a sample of data, right? So that is given. And then we need to put our data engineering and machine learning skills together to somehow come up with a solution to address the problem that is given to us, right? So just coming up with a solution is not good enough. We need to make sure that whatever the solution will be a model. It might be something else, but if it is a model, we need to make sure that we evaluate the model, right? So we can't just come up with a model and say, okay, go ahead and use this, right? So we need to evaluate the model, right? So we use this testing data set, which is should be a part of the training data set, but it should be, it should not, we should take it out before we use it as training data. And we use that to evaluate the model, right? So there will be errors. I say error because maybe we don't get the quality that we want, right? So we evaluate the model, we get some feedback of how good this model is. Sometimes we may have to do some testing on the ground to check and see how good this model is, right? And if there are issues, what we can do is we could try to fix the data engineering, the machine learning algorithms that we have, and try to see whether we could improve it, right? So we can do some iterations on that. But if it is not working, sometimes we may have to go back to the problem and see whether we have understood the problem properly, or do we need some more additional data to get this going, right? So we have to do that, right? So once we have got that done, my picture is on top of the slide, but what we have there is actually, let me put it here, right? So what we have there is a visualization, right? So we can actually do the decision making. We can use this model that we have been given for decision making. How we present the results is up to us. In most cases, it will be a visualization that we do so that people can easily, people in the domain, people who need to make the decision can easily look at these results, understand the results, and take the decisions. Sometimes the decision might be just a yes or no, right? So that's very straightforward. Sometimes it might be a kind of a, in this case, I'm showing a spatial visualization, right? With respect to disease propagation, we would see what are the hotspots and things like that, right? Yeah, so going back to what I said earlier, we are looking at the skills that we need, right? So with respect to education, the technical skills that we need, and the soft skills that we need, right? So I'm going to take one of the examples that I showed you earlier and go through some of the steps that we went through when we tried to solve that problem, and try to highlight some of these skills that you need to have when it comes to being a data scientist. Right, so the example, the case example that I'm taking is this case on dengue forecasting, or what you call trying to forecast the dengue cases. If I give you a little bit of a motivation as to why it is important, right? So if we can, we can do eradication, right? So normally what happens is we would wait till there is an outbreak and then go and try to clean those areas, but that is too late. Can we forecast what is going to be a hotspot in the next 2 weeks, so that we can go there before it becomes a hotspot and clean that area out of mosquitoes? Because not mosquitoes, actually clean the breeding grounds of mosquitoes, so that mosquitoes won't breed, and mosquitoes would not transmit it to humans, and the humans will not transmit it back to mosquitoes and also to other areas, right? So that is the objective motivation behind doing it, right? So if that problem is given to you, what are the data sets that you need to have, right? So I said that mobility, because people are moving, and it's not the mosquitoes that are taking dengue from Colombo to Jaffna, it's the humans that are taking the dengue from Colombo to Jaffna, right? So we need to have some indication of mobility, right? So one way of looking at mobility is using mobile network big data, or what we call these call detail records, right? So right, so using that, we are able to get some indication of how people are moving, right? So in addition to that, things that we know, if you look at other people who have done tried this problem, things that we know, population, it depends on the population. If there's a highly populated area, there's more possibility of this disease spreading, right? And also something, because it's related to mosquitoes, we know that rainfall, the temperature is a key. Not only that, whether it's more kind of a area with vegetation, with trees that would be more conducive for mosquitoes to breed, right? So that is something that that could help us, right? And obviously we need the dengue case data, right? We need to get the case data, otherwise we don't have a class label or a predicting attribute, right? So this is a few of the data items or data collections that we would need to solve this problem, right? Right. So yeah. So if I go a little bit more into detail with respect to the input data sources, right? So I don't want to spend a lot of time, right? So dengue cases, we can get it at a certain granularity, maybe the medical officers, MOH areas, or and also we can get these what I said, mobile network big data or call detail records. When you take those data, we need to make sure that we preserve the privacy and we pseudo-anonymize the data and take it. We can take the temperature, rainfall, and we can also get the vegetation I told you, maybe using satellite information, right? So that's something that we can do, right? Yeah, so let me come to the first task that we need to do. Once we have the data, we need to do a data cleaning. We need to do data mapping, right? So an integration. Data cleaning is where we have to go through the data to find whether there are missing values, right? Or data entry errors, or what you call device errors when collecting the data, or maybe saving the data, because we are sometimes dealing with big data, large volumes of data. Sometimes when we save data or when we store data or transmit data, there could be errors, right? So we need to look at those things, right? Inherently, there could be issues in the data. That's the first thing, data cleaning. In addition to that, data mapping or integration, right? So in this case, the case that I took, in certain cases, it's very straightforward. But in this case, it's a little bit challenging issue, because we are getting the dengue cases maybe from MOH areas, right? I mean, hopefully you know what MOH is. MOH is a medical officers. I think these days with the dengue cases, we are talking about MOH areas, Gram Sevak areas. Those are the administrative areas that we have, right? So if you get the cases at that granularity, we call it the granularity, right? So for that area, whether we might get at a certain other granularity, and maybe the mobile data we get at another granularity, because mobility depends on how to infer mobility from this data depends on the base stations, right? Where the base stations are, right? So that would be in another level of granularity. So how do we put all these three? I mean, I'm just showing you three. Satellite images would come in another granularity, right? So how do we put all these things together, right? How do we integrate this, right? So that is where we need some of our skills, right? Definitely the mathematical skills that we have, geometry skills that we have, we need it. The computer science and engineering skills we need it, right? So in most of the cases, I mean, we can't handle. So for example, if I take the mobile network, we call it mobile network big data, right? So we need to come up with engineering solutions to do this, right? So processing the data, right? So we can't just design one approach and say, okay, this is done, we are good to go. No, we might have to try different things. We might have to do certain things and come back and do again certain things, right? So we need engineering solutions to do it in an efficient way, right? So science always tells us what can be done, but engineers are the ones who actually do the things, right? So right, so we need programming skills. Definitely we need, because this data is coming from different sources. We need our database skills, right? And a little bit of machine learning skills also we may need for the data cleaning. Sometimes we use machine learning to clean the data, not to build the models, but to clean the data, right? So and also, as I told you, scalable computing, big data, right? Being able to handle big data. And also at this stage, sometimes we need visualization skills also, because we may want to look at how the original data looks like, not at the final stage, but here we would want to look at how the original data looks like, whether our data integration has worked properly, right? To look at some of the samples of data and look at the visualization, right? Right. So if you take our problem of dengue kind of case forecasting, something that we need to do is to look at what are the existing work that has gone into, right? So if you are given a problem, first thing, we don't just jump into the problem without looking at what other people have tried, right? So it's always good to look at what other people have tried. In this case, we see that there are statistical models, we see people using neural networks, we see people using support vector machines. Agent-based modeling is widely used, right? So when it comes to COVID cases these days, a lot of people are using agent-based modeling because there are some statistical models that work for disease propagation, traditional statistical models, and we can actually use agent-based models and complement each other and try to come up with better results, right? And there are lots of other computational models, but the important thing I'm going to show here is that you need to know your machine learning models, and you need to look at what other people have done. In addition to that, we need to look at, we already looked at the data, right? But we need to look at what are the data sources other people have used, right? So that we can identify the data sources that we should look at, because we can't throw all the data sources that are out there and expect, because that is going to be very expensive, right? So having an idea of what are the data sources that have worked would be good, right? So in our case of doing this dengue forecasting, we saw or we did the data pre-processing and feature engineering. Here are some highlights of what we have done, right? Right. So, So with respect to mobility, we have to make some assumptions, right? A lot of data engineering goes into modeling the mobility with large volumes of data, right? And then when it comes to using the vegetation data, we have to make certain assumptions, right? And yeah, so I will what I want to the point that I want to raise here is that we have to spend a lot of time, effort in cleaning the data and coming up with a good set of data or acceptable set of data that we will get some good results. Not only that, after we clean the data, we may want to look at certain correlations across attributes, so that we find out what correlations are good, what and certain other correlations may not be good, right? So so with that, we understand what is working and what is not working, right? Right. So after we do that, we in the pipeline, we have to try different machine learning models. We can't just take one machine learning model and try. Also within machine learning models, there are what we call these parameters for a given machine learning model. Some machine learning models will have different sets of parameters that we need to optimize. If you just take it as it is, as the default, you may not get the best results. So you may have to do some form of optimizing, right? So you may have to do identify what are the actual parameters that work and what are the parameters that may not work, right? So that is something that we need to do within machine learning models, right? So therefore, an understanding on good machine learning models, not only that, the skill of perseverance to try different models is very important, analytical skills on trying different models, right? And just trying the models is not good enough. We need to know, we need to be able to gauge whether how well we are doing, right? So we need to have an understanding of the performance measurements that we can use, right? So most of these are statistical performance measurements that we have, right? So good understanding of statistics. Knowing just applying the statistical tool is not good enough. We also need to make sure that we understand the significance of those numbers and what do those numbers tell us, right? So that is a skill, an area that you need to have, right? So measuring the performance of the model is something that you have to do if you want to succeed, and for that you need to have the background knowledge, right? As I told you, the parameters keep changing, right? So, not changing, parameters, the best possible set of parameters are required. So sometimes you may have to go for, we call it in general, hyperparameter optimization, right? So where we might want to look at what is the best collection of parameters, right? So given model, 1, 2, 3, 4 is not what we are talking about. Within a model, we have to look at various possibilities of that model with different parameters, right? So something that we have to do, right? So I'm showing here in this example where we have done a little bit of parameter optimization using a genetic algorithm, and I show how the results go up as we for the single model, but I mean single machine learning model, machine learning algorithm, but still with the hyperparameter optimization, we see how the results get better, right? So in a competition like this, especially at the initial stage where it's just a machine learning competition, you might want to try some hyperparameter optimization so that you can, within a model or within a learning algorithm, you can still continue to optimize. This is kind of a final slide of showing how good the results are. We can only say this for the test data, right? So the red line shows what we had, the actual data, and the green line shows the predicted value. So by looking at something like this, we can get some confidence that we are maybe we are doing the forecasting right. Right. So that is what we want. Right. Once again, I remind you, what we are trying to do is trying to forecast it 2 weeks ahead for a given area, right? Not for the entire country, right? Predicting it, forecasting it for the entire country is easy, but we should be able to forecast it for a smaller area so that we can go and, if it is a high volume area, highly spreading area, we can go and actually take, if it is going to be a area that is going to spread the disease very rapidly, then we can go there and try to take some measures to stop that, right? Yeah, so I mean, this graph is good for us to get an idea how good we are doing, but for final decision making, we need to show it something like this, where we maybe show it on a Sri Lanka map or a geographical map, and we show the hotspots where it is going to be red for the next 2 weeks or the week after that, or I mean some kind of temporal dimensionality. We should be able to show it, right? So let me go back to my set of skills. So right, so all the steps that I showed you required certain skills. I highlighted certain skills, but if I come back to the skills, especially at the final stage, you need your technical skills, once again, the visualization skills, and I mean and also the soft skills you need very well here at the final stage, being able to tell a story and being able to do a good presentation, right? So is going to help you, right? I did not touch on some of the other technical soft skills, right? So but it's obvious, right? So when you are working in groups, as I told you, data science is not something that you can do on your own, right? This competition is also encouraging you to start off or have a group of 2 or 3 people, right? So that's a very, very important skill that you need to have in data science, because you can't look at everything, right? So you need the support of other people. It's the success of the team that will take you to the top, right? And to work in teams, it's important. Communication is important. Finally, we need the communication skills to communicate the outcome. Initially, we need the communication skill maybe to get the data, right? So in some of these problems that we try to solve, we have to be able to communicate well to the stakeholders and convince them, okay, you need to give this data to us so that we can do this. We can do a significant change to the way we are doing things, right? So I come back again to the skills, right, of what I said earlier, the important skills that you need to have when it comes to data science. Because of the time, I will proceed further, but I will once again come back to it, right? So although I say that you need to have these skills, how do you check whether you have these skills, right? So we have a very good opportunity, golden opportunity, with what Rotract is doing and sponsored by Octave, and also sponsored by Hackathon LK, I think, right? So yeah, so these competitions can be the place where you can check your data science skills, right? So Data Storm is one example. KDD Cup is there. I highlight KDD Cup because a long time ago, when I was an undergraduate, and not undergraduate, actually postgraduate student, we didn't have all these competitions around. It was only the KDD Cup that was there, was conducted by one of the major data knowledge engineering conferences. right? So that is still there, but it doesn't get the prominence that it got 15 or 20 years ago, right? But we have Kaggle, which is a very good platform out there for you to check your skills. And also there are a lot of resources out there where it will help you to learn more. I mean, there are even courses out there that would help you to get started on data science that would inculcate the skills that I told you that we need here, right? So DataStorm is what you are here for, right? So you can use that. DataThon actually was a competition that was there about 2 years ago, and driven data is also another competition. There are lots of, this is not an exhaustive list of competitions that are out there. I picked driven data with a specific reason of what I have on my next slide, right? So driven data has a special case or special competition. It's still running live. Actually, I took this slide this morning, right? So it's called Dengue AI. Right. So what I wanted to highlight is that they have given some data set out there and asking us to try to see whether we can forecast the numbers. Right. So being a group of people who work in this area, we encourage our students to try that. And so what I want to highlight here is that if you look at the leaderboard, we have a group from Sri Lanka, actually from University of Moratuwa at the top, and it's at the moment it's not that active, this competition, because the submission that they put in 2019 still is at the top. So actually what that means is the solution is so good, nobody has been able to get, I mean, there are submissions coming in, but nobody has been able to top it any further, right? So I would encourage you to, I mean, I would show this slide as an encouragement for you to show that being Sri Lankan students, these are Sri Lankan students, right? So at the moment they are working somewhere, I don't know where, but what I want to show you is that being a Sri Lankan student in a university in Sri Lanka, still you can beat the world, because this is open to the entire world, right? So you can do it. You have the capacity to do that. Right, let me give you a kind of a final thought on what I'm kind of encouraging you to do, right? So if you want to be in the area of data science, what I am, what you call the secret formula that I'm giving you is, it's not a secret formula. The formula that I'm giving you is you try to find a challenging competition, right? With respect to, now I showed you some examples of competitions or challenges that you can take, right? And then take part in it, right? Check your skills as a group, as an individual. You can do it as an individual, but I don't encourage you to do only as an individual. Try it as a group, as an individual, right? And then when you do that, you will be able to identify the gaps that you have, right? So I mean, you can't just, the gaps won't just come down from sky to you, right? So once you try to submit solutions, if you are not performing well on the leaderboard, that would indicate that your solutions are not as good as what the others are doing. Then what you can do is go to the forums. Almost all these competitions have forums. Go to the forums and check and see what these people are discussing about, right? And if you find things that you don't know, what you should do is try to find about that. Take a Coursera course or take some other course that would help you to understand those things that these people are talking about, the other people on who are succeeding, right? Always when you are going to the forum, try to look for, forums are, you should be able to search and find what you're looking for, and also to read things that are put by people who are successful on the leaderboard, right? So that is from them we can learn the gaps that we have, right? And then the next step is learning, right? So I told you, you have to be lifelong learners, right? So you need to try to learn those things. As I told you, you could use Coursera, you could use other means of things that are available. There are lots of, especially because of the increase in the interest of data science, there are lots of content out there, but make sure that you select good content and follow and learn. right? So once you are equipped with that, you need to find another challenge, right? Because you are not done there, right? So you find another challenge and continue to go in this cycle of learning to become a successful data scientist. Let me wish you all the very best to become a successful data scientist, not only for your own individual gain, but for the good of the society, because the case examples that I gave you can do a lot of good for the society, right, through data science, right? So let me encourage you to go through this cycle of learning so that you can become a great data scientist. Thank you, and I think we will try to take some questions if there are any questions.
Thank you, sir, for that insightful session. With that, let us move on to the Q&A session. Our participants have submitted some interesting questions, sir. So let me start off with the questions. Right. The first question is, what are the examples for commonly used algorithms in machine learning?
Yeah, in the session, actually, I showed you, as I told you, there are lots of, I mean, this question is qualified as saying commonly used, right? So you should not go with thinking that the most popular algorithm would work. As I told you, for the given problem domain, there will be certain algorithms that work, right? So with respect to popularity at the moment, neural networks, deep learning, I mean, deep learning is based on neural networks, right? Decision trees are kind of machine learning algorithms a lot of people use. But as I told you, we should not all go just because it's popular or a lot of people are using it. We should go because it can solve the problem, and also you should try. But I think it's a very good question, because as a practitioner, you would want to know what are the machine learning algorithms that you need to learn, right? So depending on the problem that you are trying to solve, you try to acquire that knowledge into that machine learning algorithm. But you should also have a set of machine learning algorithms that you are familiar, right? So I would say being familiar with some kind of neural network approaches or deep learning approaches, and also decision tree based approaches like random forest and things like that, and also a little bit of kind of Bayesian models that are out there would be good to have. But as I told you, there's so many variations, so many machine learning algorithms, so you can't be a master of everything, right? So depending on what the problem that you're solving, you should try to. You should also not try to use your favorite learning algorithm on a problem that it is not suited for. Some people try to do that, right? So that would not work, right? So yeah, hopefully I answered the question.
Thank you, sir. Okay, another question. When learning the tools for data science, what should be the tools recommended for a beginner?
Yeah, okay. So I'm wondering what is, I mean, when you say tools, in the pipeline that I showed you, there are a lot of tools that you can use, right? So let me go to the pipeline where I had this. Yeah, right. So right, so the data engineering, and I mean, at the moment there are these what you call everything in one box type of tools that are out there, right? So for, I mean, some of these big vendors in data science and data mining, they come up with I mean, most of these database vendors now come up with what you call data science toolboxes, right? So that would have their own what you call pre-processing, data integration, machine learning, data visualization, everything put in together, right? So there are things like that, and there are also open source frameworks out there. But once again, it depends on what you're trying to do, right? So sometimes you might not be able to do things with tools. You might have to write your own code, right? So the tool that you have might not, the data that you have might not fit into that tool, right? So I would not want to name certain tools here, but would encourage you to look into certain machine learning algorithms as tools and certain data preprocessing algorithms. I mean, for example, when it comes to data preprocessing, I told you we need to do data cleaning. Sometimes when we are doing data cleaning, we need to fill some gaps, right? So fill some gaps, right? So sometimes we don't want to throw the data out because it's there are some missing values. We would like to put up, because there is a lot of other information that is important there, right? So therefore, we don't want to throw that row of data. If you have millions of data items, we can throw it off. But if you have a smaller number of data items, we have to keep it, right? So there are tools like data imputation, right? We call it, right? So we try to use some techniques to try to fill those places before we use it, right? So therefore, because there are so many commercial tools and open source tools, I don't want to name it, but I would suggest that you need to categorize go into the pipeline and look at the different stages of the pipeline and try to find certain tools. Because I don't want to say you need to learn Python. I don't want to say you need to learn C++ or C#. We don't use C++, or sometimes we have to, right? So yeah, right. Okay, when you take Python, there are lots of Python libraries, right? So I would suggest my formula: go to the challenge, right? Try a challenge, because it's a lifelong. I mean, you can't be. I don't want to discourage you. You can't become the data scientist with one competition. You need to go through multiple competitions. Each competition that you go to will show you. I mean, if you come into a challenging situation, we'll show you what you need, and then you will try to find out what needs to be done. Do it a little bit wisely, looking at what other people are doing, and then select those tools and learn, right? Yeah, so, okay. Right, anything else?
Yes, sir. Okay, they're asking what is exactly meant by data mining. Just curious because of the questions you have. Yeah.
Yes. Data mining is a kind of an old term. When I was doing my postgraduate studies, actually, I would have called myself a data mining engineer, or not a data scientist, but an expert in data mining, right? So actually, I mean, data science. The term data science has come into being now, and it's widely used, superseding the term data mining, right? So data mining, I would say, was I mean, it has its own meaning, right? So let me try to give the meaning to you, right? So what we are trying to do is, it's a bit of a misnomer, right? Misnomer means the term itself means something else, right? So we are trying to mine through, like gold mining or silver, or some other mining, gem mining, right? So we are trying, I mean, inside the earth, there's this precious metal or precious stones, right? So we need to search and find that, right? So the term data mining comes from that, but actually, in other words, and not only that, parts of big data processing, all those things are part of data mining. But I would say that it's a term that was used earlier, and now the more trendy terms are the data science, the big data, which is actually doing data mining, right? So I will stop it there. Right.
Right. Thank you, sir. Okay. There's another question. What are the best algorithms used for sound recognition? Best algorithms.
Sound recognition? Oh, what do you mean? Maybe analyzing what you call audio, or audio data, right? Or yeah. So at the moment, we because of the, I mean, there's a huge revolution taking place with deep learning, right? So where, I mean, the neural networks and deep learning has become kind of a de facto solution for everything, right? So we can always throw the problem into that. And I mean, I'm not saying everything is solved by that. For example, these self-driving cars and all sorts of things are using a lot of things that we have, right? So I would say, rather than naming a specific, I mean, when you try to do processing these sound waves or sound signals or audio data, you need to do a lot of pre-processing, and there'll be a lot of algorithms that we need to do to pre-process. There are different approaches that we can take. Sometimes we go with the features, sometimes we go with other ways of looking at it, right? But I would say deep learning approaches are showing a lot of promise at the moment when it comes to because I'm not exactly sure where this question is coming, because it has, I mean, it's very general, right? It has to do with once again what you're trying to do, right? So based on what you're trying to do, it depends, but I would say in general, deep learning approaches are showing a lot of promise at the moment, right? The deep learning is quite vast. I mean, it has grown into different areas, different variations are there, right? So therefore, and deep learning is made possible because of the computational power that we have now, right? So it was not available a few years ago, right? Or 10, 15 years ago, it was not available, right? So with the ability of processing power that we have, that's another important skill I told you, right? Being able to come up with engineer solutions, computational solutions, right, to do the deep learning, because deep learning requires a lot of computational power, right? So with that, I would say deep learning approaches would be a kind of a direction to go, right? Yeah.
Right. Thank you, sir. Okay, another one. What is the most preferred language as a programming language for machine learning? Yes.
All the questions up. Yeah, so I think there are these leaderboards that actually show. I've not looked at it recently as to. I mean, good questions, because you need to know what to look at, right? So, when it comes to databases, we can look at. I mean, I teach mainly databases, right? So, for databases, we can look at applications. What databases are most popularly used, right? So that we can concentrate on those databases, right? Similar to that, programming languages are also there, but I think this would be an easy question, because you're asking for machine learning. So I would say Python. Python would be Python could be taken as because there's I mean, R is also there, but I would say Python with a bit of a bias from my background, right? So yeah. So once again, it's a harder question to answer, but I would say you learn one language, but when it comes to programming, it's not a case of, I mean, unless you want to do something very, very difficult, isolated thing, then you would need a certain skill in it. But if you get the general programming skill with some programming language, right, then you should be able to apply it, right? So for example, at the moment, I mean, you go to a certain tool set, right? You have a solution available, or you want to adapt to or use that solution. Unfortunately, it's written in Scala. Scala is another language, right? So how do you do that? But if you have the basic programming skill, you should be able to learn a little bit of Scala and use it. So what I would say is, don't try to fall into this bandwagon of doing the most popular language. But I would suggest Python or R or something like that. But don't think that is the only language that you would need, because you should be, once you have the skills of programming, you should be able to go into another language and still do it, because the basic concepts are, the programming concepts are the same, right? There are, I mean, different libraries. It's not a case of, I mean, how to use a library would be the same when it comes to Python, and when it comes to, I mean, what syntax you are going to use would be different, but how to use from a semantic point of view would be the same, right? So yeah, my advice is to learn a language and make sure that you learn it well, so that you can use other languages also, because in our case, we will come across so many different solutions in where they have been using different types of languages, right? Okay.
Right. Okay. Thank you, sir. Okay, only 3 more questions, sir.
Right.
How and why to make optimum use of cloud platforms like MS Azure, AWS? Why do we need to try to learn them?
Yeah, so these, yeah, a very good question, I think, because I told you, because now, because of the computing power that we have, we can try. I mean, one thing that we can process large volumes of data now. I told you my background when I started learning, what I learned was data mining, right? Long time ago, 20 years ago, we didn't have this processing power, right? So we had to write our own. If you want to distribute us, if you want to do parallel computing, come up with a parallel computing solution, we had to write our own parallel computing code to do that. But now things are so easy because everything is made available, right? So databases are available on the cloud, machine learning algorithms are made available, data processing algorithms are made available, right? So I mean, if you take things like Azure, right? So all those things are available on the cloud. You have to pay, I mean, you have to pay some money and use it, right? So that gives you a much bigger power of computing, right? The fact that you can handle large volumes of data, and the fact that you can then try multiple models. I told you, right? So one single model would not work, right? So there would be situations where we have to try multiple models, right? Right. So even a single model sometimes would require, right? So some of these big, deep learning algorithms would require quite a lot of time, right? So I can give you a small example. Currently, we are looking at identifying vehicles by processing the videos, right? To learn that, right? To learn the model using a deep learning model. It sometimes takes, I mean, depends on the computing power that you have, the computing power that we have. It sometimes take 2 weeks to learn this model because you have a large volume of data, you have a large network to train, right? So it takes, right? So that's why it's important to learn have an idea of these cloud platforms and what is available on these cloud platforms, so that you can harness that power that is made available from these cloud platforms, right? So that is why we would say, right? So one area is the fact that you can handle large volumes of data through these resources. You don't have to maintain, you don't have to build your clusters to do that, right? The other thing is that you can try different models. You can try bigger models that require a lot of computational power because of the cloud resources. I would like to give one small difference. I mean, there are certain data science applications where we cannot try on cloud platforms because of, I mean, if you have your own cloud, you can do it, right? But you can't do it on public clouds, right? So because of privacy and things like that, in those situations, still you need to know the cloud technology, even to run it in your own, to run it on your own cloud platforms that you have, right? Yeah. Yeah.
Okay, thank you, sir. The last 2 questions are actually kind of similar to each other, so I'll just combine the 2. So here they're asking, what kind of advice would you give for an undergraduate? And is it better to work as a data scientist in foreign or Sri Lanka, because data science is relatively new here? Like they're also asking what research opportunities are available for the university undergraduates at UOM or elsewhere. So yeah.
Yeah, I would say first part is actually asking whether to work in Sri Lanka outside, or it was not clear to me.
Yeah, okay, yes, whether to work in Sri Lanka or in another country, because data science is relatively new here. Yeah.
Yeah, okay. So although data science is new, I would say, because our people are not making decisions based on data, right? But our companies in Sri Lanka, like the software companies, are doing a lot of work for other countries, right? So I would say there are lots of opportunities for data science. I think Octave would vouch for me, right? So Octave needs a lot of data scientists to work to solve problems in Sri Lanka, not only Sri Lanka, to solve problems outside also, right? So there's a lot of opportunities, and preferably I encourage people to work in Sri Lanka, because that can support our economy and take this country to a different place right? So rather than using your skills, I mean, it's okay to work, but you get the opportunity to work out, to solve problems that are outside, also from staying in Sri Lanka, right? So as the undergraduate, I would suggest, if you are keen on data science, I would suggest that you take, I mean, if you have the option of choosing courses in your degrees, right? So unfortunately in Sri Lanka, we put boxes into the degree programs and we don't allow any flexibility. But if you have the option of choosing, I would suggest you to choose the things that I told you, right? Take mathematics courses that you may not have taken, take some machine learning courses if you can take a basic data science course if it is available, visualization course, right? So as an undergraduate, try to take these courses, or else if you are in one of these boxes, as I told you, the degree program is boxed already for you. In that case, what I would suggest you to do is the same formula I gave you. Try some challenges and then do some Coursera courses or some other courses that are out there that would help you to improve your skill. Because with a degree, right, undergraduate degree, and these additional data science skills that you have, you should be able to secure a job. Because I told you, domain knowledge is also important. You might be coming from a different domain, but you can be a data scientist for that domain, right? So you have a key advantage in that arena, because you have a degree in this domain, and also you have the data science skills. And also, I think something I forgot to tell you, I planned to say that earlier, but thanks for this question, right? So if you compete in platforms like Kaggle or other platforms similar to Kaggle, you can build your profile, right? So people who interview you, or people who do the job screening, would look at the Kaggle ranking that you have, right? So if you have a good ranking in Kaggle, you can use it as an advantage to get the job or get the opportunity that is out there. I think there was a last part to this question of research. I would say there are lots of research opportunities out there in universities, right? So at Moratuwa itself, we do have a center for data science, and we try to, we can't do all the problems, but we try to take problems and try to solve those problems. I gave you a few examples here, right? But there are so many other examples, opportunities. If you have the data, if you have a problem that can be solved with that data, if you have the human resources, right? Human resources or the research students who are keen to work on a problem and solve the problem, obviously we can do a lot to improve the situation, so that we can encourage this data-driven decision making in society, right? Not for your, it will give you an individual advantage, but not only that, as I said, it can benefit the society also, right? Yeah.
Thank you, sir. Well, sir, those are all the questions submitted to Slido. So I hope everyone, like all of your doubts have been cleared. So let me offer heartfelt gratitude to our speaker for helping these young data enthusiasts to learn the skills needed to become a data scientist by sacrificing your time. Thank you, sir.
Okay, thank you very much for organizing. Right.